All right, next exercise is a seated leg extension, and that's just where you're sitting on the edge of a table and you kick your leg out in front of you like that. Super straightforward. So, just like last time, first we're going to figure out which muscle group is actually working. So, if we're doing this exercise and we just relax, then gravity is going to pull us down into knee flexion like this. We know that the working muscle group is a muscle group that performs the opposite motion. So it's the knee extensors or the quadriceps. Again, we know that these muscles are going to be on during the entire motion. So they're on during the concentric, they're on during the eccentric, and if we decide to hold it in a static position like this, they'll be on during that isometric position as well. The muscles that perform the same action as gravity, they can be relaxed the whole time. So gravity pulls us into knee flexion. So the knee flexor muscle groups, in this case the hamstrings, they can be relaxed the entire time. Again, they don't need to be on because gravity is already pulling us into knee flexion, so we don't really need the hamstrings to be on. Now, when determining the type of muscle contraction, again, same rules as before. On the way up, when the limb's moving up, we know that muscle is causing that, and so in this case, the quadriceps are causing the motion. They're concentrically contracting, which means they're on and shortening, and the internal moment is greater than the external moment. When the leg is moving down like this, we know that that motion is caused by gravity. So muscle's not causing that motion, gravity's causing it, and muscle's just controlling the motion so that we don't just flop down. When the muscle is controlling the motion like this, we have an eccentric contraction where the muscle is on and lengthening. And in this case, the external moment is greater than or overpowering the internal moment. Last thing, looking at moment arms. When the knee is extended like this, gravity is pulling down on my lower leg. And let's say gravity is pulling down at this part of my lower leg, and this is the line of force. You can see this line of force is pretty far away from my actual knee joint, so we have this big moment arm between the line of force and the axis of rotation over here. So because gravity is acting on this big moment arm, gravity can cause a lot of torque trying to pull me into knee flexion. So my knee extensors need to produce a lot of torque and they need to work pretty hard to counteract gravity. On the other hand, when my knee is in 90 degrees of flexion like this, gravity is still pulling down on my lower leg. Okay, gravity is still there. But now, if we look at the line of force is passing right through my knee joint, is passing through that axis of rotation. So because of that, there's no moment arm. There's no distance between that line of force and the knee joint. So gravity doesn't actually exert any torque on that knee anymore. So again, gravity is pulling down on my leg, but it's not trying to rotate my knee or it's not trying to flex it. So my quadriceps muscles don't really need to be on. They can be pretty relaxed as my leg just kind of dangles here.